Hello, in this video I'm going to show you some examples of derivations that are quite similar to the actual homework derivations. They're very similar. Okay, so we'll start with this one. We're going to show that this sentence is, we're going to derive this sentence. And what is the sentence? It says, if P and not Q, then it's not the case that if not Q, then not P. Okay, so this is a conditional, so we're going to assume CD. Now we can go ahead and simplify line 2, but once we're done with that, we're kind of stuck. The derivation is stuck. Well, so that means we should do a subderivation. What subderivation to do? Well, one that will complete the derivation. Let us box and cancel. What will let us box and cancel? The consequent of our show line, not, if not Q, then not P. So the consequent is a conditional, so let's show that. Okay, good. We should make an assumption. Cannot do assume ID because this is not a conditional, so we'll do assume ID. Okay, well now we have this conditional, so let's see if we can use it. Can we? Sure, we can do 4, 6 modus ponens because 4 is the antecedent of 6 and that gets us not P. What can we do with not P? Well, it contradicts 3, so we can bring down 3 and we have an indirect derivation. Well, good. 5 is the consequent of line 1, so we have 5 CD. Okay, so we say assume CD, we apply some rules. If we get stuck, then we try to show, when we're trying to show a conditional, we show the consequent, make an assumption. It's an indirect assumption, try to get a contradiction. So that's that. Okay, now this problem is a lot like 245, and it also will be helpful with which problems. If you look at it with 134 and 135, it's quite similar to 134 and 135. Okay, so let's go ahead and show the conclusion. Now this is a biconditional that we're trying to show. We're trying to show if P then Q, if and only if either not P or Q. That means we need to show this conditional, which is the left to right version, and also, and completely separately, we need to show this conditional, which is the right to left version, and then we'll put them together, and that is a direct derivation. So in a way, there are two separate derivations inside of what looks like one derivation. First you show the right to left conditional, and then you show the right to left conditional. And this is talked about in the derivation setup. If you look at the derivation setup handout, you'll see this format, where you have, when you're trying to show a biconditional, you show both of the conditionals. Okay, good. So let's show that if P then Q is true, then either not P or Q is true. So we'll make a conditional assumption. What can we do? Nothing. Derivation is stuck, so we should do a subderivation that will let us complete the derivation. What would that be? It would be show consequent, because if we can get this not P or Q, then we can say for CD. Right? Whenever you're trying to show a conditional and you get stuck, you want to show the consequent. Okay, so now we have a couple of options here. If you've proven Theorem 66, which you should because it's laid out for you in one of the videos and you can just follow along and do that as the video goes along, and that's what you should do, you can say assume ID here. You can do that anyway, but then we can apply DM and we get a conjunction. Okay, well, what do you do with a conjunction? You simplify it. And let's simplify both sides so we don't forget to do either simplification. So can we use 7 or 8? Sure, we can use 7 or 8 with 3. The quickest thing to do is to say 3/8mt, and we get not P. And hey, that contradicts 9, so we can say, or excuse me, 7, so 7/9id. And then we say 4CD, and we have done the left to right direction of the conditional. Good. Now, we could have done this differently, but this is the quickest way to do it, and it's just we're trying to show a conditional, so we assume that the antecedent is true, assume CD. When we can't do anything more, as we can't, then we immediately try to show the consequent as a subderivation and make our indirect assumption. Once we have DM, we can then apply it to line 5, which gets us a conditional conjunction, which we can then split up and use pretty straightforwardly to get a contradiction with out of 3. Okay, now we need to show the other conditional. This is the right to left of line 1. So we're going to say assume CD. We can't do anything with 13, so we're going to show the consequent again. So we'll say assume CD. So can we use 13 together with 15? Well, not as it stands, but we can do double negation with 15. And that means we can do 13 and 16 MTP now, because 16 is the negation of the left disjunct of 13, and that gets us Q, and that's what we need for CD. Now, and that lets us complete this side of the subderivation. And let's see, I want to show you something an issue that might come up, that will come up in some of your homework problems. It doesn't come up here. You could say show consequent here, and you'd say assume ID. Okay, that's not necessary, but if P hadn't interacted with, if 15 and 13 didn't interact, then you would want to do this. You'd want to say, okay, well, I'm still stuck. What should I do? Something that will help me box and cancel. What would that be? Getting the consequent of line 14. So the point is, if you are stuck after you make this assumption, if you're trying to show a conditional, if the derivation is stuck and you say and you introduce this conditional, and you say I'm going to try to show a conditional, and then you make the conditional assumption and you're stuck still, then try to show the consequent again. Yeah. In this case, that's not necessary, as we saw. Because that P is enough for us. So we get if P then Q, which is the consequent of 12, so we can say 14 CD. Okay, now we have 2 and 12, which are two conditionals, the converse of one another, the conditional going in one direction, the conditional going in the other direction. So we can put them together with CB, and we get our conclusion, and so that makes this a direct derivation. Okay, so this is very much like how you want to do Theorem 45, and it's relevant to doing like 134 and 135 as well. So there you go. If you have any questions, please let me know.